We're standing outside the corner of Trafalgar Road and Highway 5 or Dundas Street in Oakville. Oakville has seen a huge amount of construction growth in the last 30 years. In fact, this entire area 35 years ago was farmland. Now, if you want to be an electrician, you're probably thinking your future lies on the top of that building. Then that's a good possibility. But the question I put to you is, what does this have to do with that? I've spent most of my adult life working as an electrician, both in construction and on the other half, on the cookie side. Construction is a funny thing. You get to enjoy watching a building being constructed from the ground up. Other than plumbers, our two trades are the only ones that set foot on the site and are the last to leave. Heck, we even leave after the plumbers. We turn the lights out as we go. The nice thing about it is that you've got a beginning, a middle, and an end. You know when it starts, you know what to expect. It comes pretty routine, you get your skills and you're sharp, and at the end, you have a good satisfaction because you've completed the job. But building construction is only one small facet of it. Because as electricians, our construction part also does traffic lights. We also do road work. We do not just apartment buildings, but we do a small industrial, large industrial, housing, commercial like retail. We cover the entire gamut. And they all have a variety of work and different problems to solve, but for the most part, you go in, you do your job, you go home. But if you're going after a 309 license in the province of Ontario, that's where the cookie comes in. A funny thing about an Oreo cookie, it's always the same shape, always the same colors, and always tastes the same. It's identical. They're never different. They're the same size, the same flavor, same color. Always identical. That's not by accident. A company can't afford to have you open a package of cookies and suddenly go, this doesn't taste right. You'll either buy them again or you'll think there's something wrong with them. So, again, what does this have to do with being an electrician? I can hear you asking that question because I'm asking it myself. Like, I'm an electrician. What do I care about the taste of a cookie? And in order for that cookie to always taste the same, they don't leave it to chance. They have machines that carefully measure all the ingredients. They blend them. They cook them for exactly the right amount of time. They move them along on conveyors and package them. They're always identical. The thing is, as electricians, we install the instrumentation that makes it necessary. We maintain the equipment that keeps it going, and we understand and fix and maintain the process. That's what this course is about. This video is going to give you an introduction to all the instrumentation that, frankly, is all around us.
When making cookies at home, even following the recipe, every batch will be slightly different. Different size, different shape, number of raisins in each cookie. But when you're making millions of cookies an hour, you have to make sure that all of the ingredients in baking are always the same, each batch identical. And there's only one way to do that. You call on the hidden army. Every single day, all around our planet, there is an army, hidden in plain sight or completely concealed. But we rely on this army to make our modern world operate. Without it, our lifestyle would very quickly cease to be. From sunrise, through our commute, through our workday, to our evening's entertainment, this army works tirelessly. So what is this army? Well, it's billions and billions of sensors and controllers that collectively we call instrumentation and process control. So when you hear the term instrumentation, you might think of a band playing music. Or you might think of a whole bunch of gauges, like you've seen on pumps and stuff. But we don't usually do that. You might think of the instrument cluster that you might find on a car or an airplane. But we're not mechanics. You might think of the weather. I mean, it's nice to know what to wear, whether there's a hurricane or a tornado coming. And I'm sure those weather guys got lots of instruments. But we're electricians. We don't do any of that stuff either. So I know what you're thinking. If we're not pipe fitters or mechanics or meteorologists, who cares? Why would an electrician care about instrumentation? Well, remember, I said there's an army out there. So let's take a look around us and see how big this army must be. Let's begin with our chosen profession, energy. Hydroelectric plants use falling water to turn large turbines connected to generators. The water flow is controlled by large valves that allow the water to flow down the penstocks to the turbines. The amount of power produced depends on the flow of water. Therefore, instrumentation must monitor the water's level, monitor and verify the valve position, and the water flow rate. It must also check the speed of the turbines and the generator, the output power, the heat of the generator, and any vibration which may indicate bearing failure, and all this before the electricity leaves the plant. Once the electricity is put onto the grid, remote control power stations monitor power flow and can shed loads or reallocate power as required. Power outages can be shortened by this method. The high voltage lines themselves are monitored for voltage drop or ground faults caused by solar flares. Once the power has reached the consumer, the hydrometer sends consumption data directly to the power supplier. Instrumentation monitors power flow, current, voltage drops, power factor, and ground faults. One might think that solar power does not require any instrumentation, but transfer switching between solar power and backup power requires it. Furthermore, large industrial arrays monitor the sun's position and azimuth, and each cell is turned and angled to get the most of the sunlight. You might be thinking you're looking at a wind generator, but you may not realize you're looking at a complete weather station. Wind turbines are remote and have to be as autonomous as possible, so each tower monitors wind speed, barometric pressure, blade pitch, rotational speed, voltage output, and they also measure heat and vibration. And they monitor and control their own lubrication systems. Nuclear power plants are basically large kettles. While cleaner than their fossil fuel cousins, they have additional demands on instrumentation. Water pressure and temperature, both inbound cooling and core, are carefully monitored. Radiation containment is unique to nuclear power plants. However, extra care and attention is given for local seismic activity. Water flow for both cooling and steam production is critical, as is steam pressure and flow. While sitting on a volcano may not seem like a good idea, the good folks in Iceland have used the power of molten rock to geothermically heat their homes for centuries. Now, they are using it to generate electricity. Much like nuclear power, instrumentation is mission critical to keep the power flowing and the houses nice and warm. A new form of hydroelectric generation is slated to go online in early 2022. In the Bay of Fundy, Nova Scotia, tidal waves are being used to generate hydroelectricity, a feat only possible because of instrumentation. Although the world is trying to kick the fossil fuel habit, fossil fuels will remain a serious energy provider for quite some time. The fracking and distillation process depends on millions of sensors and controls to monitor every aspect of gasoline, kerosene, motor oil, and aviation fuel production. Other key products, such as plastics, polymers, common industrial chemicals and household products are derivatives or byproducts of petroleum distillation and refining.
Water. It's necessary for all life on Earth. 70% of our world is covered by water, but the vast majority of it is useless. 97.6% is salt water, leaving less than 3% as fresh water. But you cannot drink all that fresh water. Only 1% of all the fresh water is actually potable water, that is, suitable for drinking and cooking. And to make matters worse, only 3% of all the potable water is accessible, the vast majority locked up in glaciers and deep aquifers. Canada has 20% of the world's freshwater supply, but most of it is inaccessible, and our share drops to 7% of the world's supply. Humans use water for bathing, irrigation to grow food, cooking and drinking and recreation. Without instrumentation, our water would be unhealthy. Bacteria, parasites, runoff, both natural and chemical waste, means dysentery and cholera in many parts of the world. Heavy metals and excessive irons need to be measured and removed. Instrumentation measures algae and bacteria growth, monitors effluent flow. Water treatment plants rely on accurate measurements before returning the water back to the source. The result, is safe, clean, potable water. Every step along the way, from well, stream, or lake, the water is monitored and the flow regulated. Chemical additives and purifiers are added as required in safe and effective amounts. We have long since abandoned the plow and team of oxen, or hand hewing of the soil. As arable farmland disappears from urban sprawl, rising sea levels, salination, and erosion, farmers must turn to technology to maximize every acre to feed an exploding world population. From mechanized harvesting using satellite tracking to GPS animal location and animal husbandry, the use of instrumentation in agricultural production is growing. Aerial video surveillance drones feed computer imagery software, which then use other drones to target micro applications of fertilizer, water, and pesticides. This means less pollution and more production. Scientific studies are improving crops, making drought-resistant varieties of foodstuffs and cash crops. Only through instrumentation and careful measurement can these be realized. Factory, poultry, and hog production facilities means careful environmental control. Light, humidity, temperature, airflow, sanitation, all are used to ensure proper animal growth. All feed is automatically measured and dispensed along feed conveyors during regulated feeding cycles. All of this needs instrumentation to work. Large-scale irrigation requires flow monitoring and are computer-driven to save declining freshwater resources. Satellite imaging and computer planned planting means better crop production. Dairy farming requires instrumentation to assist in the milking operation and the pasteurization process. To extend the growing season, some crop production has moved indoors. Here, the entire environment can be and must be controlled. Ultraviolet light, watering, humidity, heating, pH balance, all must be measured and monitored and controlled. All of it done with instrumentation. Whether out in the field or in the lab or in the greenhouse, the use of instrumentation will only continue to grow in the agricultural production. Once the crops have left the fields, food producers rely on instrumentation to ensure finished product safety and consistency and meeting consumer expectations. Ingredient measurements and mixer action, supply hoppers and dispensing nozzles are all controlled using instrumentation. Whether making cheese or bread, cooking temperatures, humidities, and cooking times are different for each process. Some require fermentation like alcohol or vinegar, others require pasteurization. Again, not possible without instrumentation when dealing with large-scale production. Conveyors that run the products of the cooking or packaging process must do so at the right speed, whether it's dough for the bread or cocoa for chocolate. Cans must be sterilized before contents can be filled and then sealed. whether it's vegetables, stew, or dog food. Industrial scale food production mandates instrumentation to work.
And then came eBay and Amazon. Today's global transportation industry is adopting more and more instrumentation and process control. From electronic tracking and barcode scanning to GPS tracking and high-precision weigh scales, instrumentation and process control is saving time and reducing lost goods. Amazon warehouse has millions of meters of conveyor systems redirecting parcels from supplier to air freight to courier in less than a day, sometimes even less. These machines can read and process data faster than the human eye and brain, and Decision Point redirects the parcels in a blink of an eye. Okay, by now, you have to admit, the hidden army is bigger than you imagined. But if you take a look around your own home, you would find it's there as well. From refrigerators and freezers to microwave ovens, sensors and tiny processors mean you can have your favorite frozen pizza in minutes. Whether you wake up to an espresso, enjoy baking something fresh, or leave the laundry to the weekend. Whether you like spending the day skating or having a night at town to town, even working out at the gym, that hidden army is already at work, making it easier. So maybe you're tired of the same old, same old. Then why not take a nice long trip? Modern cruisers are loaded with instrumentation. They assist in every facet of the ship's control and maintenance. Freshwater management to sanitation, to food preparation, to the engine room and guidance controls. But to get to your ship, you will likely have to travel by train or by plane first to get to the departure port. Did you know that in a normal day, the United States has more than 45,000 flights carrying 2.9 million passengers? And each has more than just one carry-on. Annually, there are over 16 million flights. In Canada, Toronto Pearson Airport handles between 44 to 50 million passengers. And even in 2020, 13 million travelers passed through. Now, every airport has millions and millions of passengers that protest, sort baggage to the correct flight, and then load every plane within 2 hours. And during the flight, the ground stations are tracking each plane to avoid a mid-air collision. All of that is instrumentation.
We have left the largest users of instrumentation to the last: industry and manufacturing. We could spend hours going through all of the devices and controllers the industry uses, but this is only an introduction. However, it's important to know some of the qualities and physical properties that can be measured. And even the following list is incomplete. Density, porosity, clarity and purity, viscosity, color, pressure and temperature. Pressure and temperature will be the focus of the first level of instrumentation. Volume, flow, level, weight. Flow and level will be discussed in level 2. Weight will be covered in the apprenticeship program. Direction, position, length, and rotation. Speed, frequency, radioactivity, and salinity. Transparency versus opacity. Capacitance versus inductance. Resistance, voltage, and current. We should be familiar with those. Well, what about compression, compaction, deflection, and refraction? Luminosity, degradation, fermentation and putrefaction, angular displacement, seismic activity, particulates, dispersion, reflectivity, humidity, hysteresis, reluctance, and permeance. As we say, these are only a small fraction of what can be measured, and each of them have a particular function within process control.
After watching that video, you're probably still wondering what it has to do with being an electrician. Yes, there are lots and lots of sensors and controllers looking after facets of our lives that are not electricians' work.
But the truth of the matter is that for every boom, there's always a bust. And construction tends to be cyclical. Right now, we've had an unprecedentedly long growth period, which has been great. But you can't rely on it to always be there. The guy that builds the car gets paid once. The guy that fixes the car keeps fixing the car until it's replaced. When it comes to being an electrician, it's a multifaceted career. All of those sensors that we talked about, a lot of them you couldn't see because they're installed and they're hidden. When they break down, who do you think they get to fix it? When they have to be installed the first time, who do you think they get? I've been fortunate in as much I used to be in construction and then I turned to industry. Started using the maintenance part of the construction and maintenance, the cookie part. It's been a long career and not a lot of installation, a lot of troubleshooting, figuring out, and fixing. But in order to start that whole process, you have to understand some basic, simple terms. So you know what we're talking about. So let's begin by figuring out what process control is. I mean, we bounce that term around, instrumentation and process control. What does that mean? Well, process control is simply saying, let's take any process that's, say, a manual process, and we're going to convert it so it's automated. Now, automation is a great idea in that it's repeatable and it's faster and takes away a lot of mundane work. But if you can't create that Oreo cookie the same, it's a wasted exercise. Spend lots of money on tooling and design and engineering only to find out that you can't make a cookie. There's been a lot of mistakes made that over the years. So what we focus on is a process that we control. In order for us to control it, we have to have defined guardrails. When you go on the highway, the defined guardrail is supposed to be the speed limit and the lines marking the roads. If you do that, you'll get to your destination. You go outside of that, you might get a ticket or you might get into an accident. So when it comes to process control, everything that can be measured and then a decision based on that measurement has to have some sort of instrument, it has to have some sort of device, some sort of sensor to say, yes, that's how much water we have. Yes, that's the exact amount of sugar you require. Yes, that's the exact amount of food color. All of that, each individual ingredient. And then the mixing process. How long do we keep the motor running? What speed does the motor go? Once the mixing is done, it has to be doled out into cookie shapes. Okay, so exactly how much cookie dough do I need to make a top? How much cookie dough do I need to make a bottom? How much cookie filler do I need? Each step of the process is carefully figured out, and then they have to determine a way to measure it. And not just measure it once, measure it again and again and again. You have to have 100% repeatability, because any change, again, it's not an Oreo cookie anymore. So the whole science of figuring out and automating a system is called process control. And the only way that process control can work is by having that army of sensors checking it every step of the way. And that part is the technology. Instrumentation is the technology and science to make process control work. You can't have it both. You can't have one without the other.